So we showed you the engine machining processes that we've done to make these engines better. But we also manufacture a lot of parts, and we talked about fashion by function. These aren't just parts that we make to make the engine look more appealing. Now, obviously, everybody likes a pretty engine, but we not only like a good-looking engine, we like a good functioning engine here at Choate Engineering Performance. So in order to do this, we've designed certain parts that we call smart parts. What these parts are they address certain issues with the OE supplier. Now, because of that, we've taken this set of valve covers here for the 6.4, as you can see, and not only have we machined a valve cover over that looks great, but we've also, on the inside of this valve cover, addressed a major issue with the rocker arm area for failure. Now, the rocker arm area for failure has led to the failure of a lot of engines because it takes out the lifter and then the camshaft. Unfortunately, with these type engines, it becomes a major ordeal because the camshaft actually is extracted from the back of the engine. So it requires complete cab removal and a very expensive repair, whereas this can eliminate a lot of the failures that we're seeing from there. Another major area of failure for the diesel engines are, because of higher injection pressures, we're starting to see more and more piston failure just like this. Now, what used to be 18,000, 20,000 psi pressure, we're actually seeing double that today. In the modern diesel engines that we're seeing for the 2020 Power Stroke engines, you're actually seeing injection pressures as high as 36,000 psi. Now that can create a lot of problems, and that's some of the reasons why the piston designs have changed so much over the years. Now with this engine we see, this is a particular engine, is a 6.4 liter. This is something that's pretty common, and we see it with guys that are running maybe tuners or higher injection pressures and higher cylinder pressures. So most folks would look at this and determine that this to be cause of failure would be a piston actually cracking. But if you really look hard, you can actually see in this area, which is known as a reentrant style bowl, this lip actually forces the combustion gases down past what we call the witch's hat and then back through, and then it reverses rotation. When it reverses the direction, it actually sustains in this area and actually creates an area for much more heat load. Now with this added heat load, because it reverses rotation, it dwells longer in this pocket here and creates a hot spot on the piston. Once that hot spot's created, because of the reverse flow from the lip, what happens is this failure point is prevalent. It creates a blowtorch type effect, and you can see that with a smooth area right here on this piston. Once that pinhole develops, it's just a matter of time before the failure takes place. What we do is machine our pistons with the different area in this lip. Now this allows better extraction for the heat in those areas right there. Also, we offer a coating, a polyolefin style coating that allows the heat to remain in the combustion chamber instead of on the piston. Because of this, we have better fuel efficiency and we have better protection of that piston in certain areas. What you're looking at here are the fly cut areas of the piston. This is obviously for camshafts that we'll use. Again, we've worked specifically with comp cams to develop a camshaft that has low shock technology and microsurface enhancement. Now what that does is that decreases the failure rate of the lifters. Instead of having a high velocity on the seat that closes at an accelerated rate, we're able to use a crack and wax style camshaft. And that crack and wax style camshaft keeps the valve train loaded so that the vibrations and the harmonics are much less than what they would be from the factory grind on the camshaft. At Choate Engineering Performance, we don't just specialize in engines, we also specialize in problems or smart parts and smart tools. What we have here is a Power Stroke socket. It fits all fuel filters and oil filters from the 7.3 all the way up into the 2017 6.7 Power Stroke. Now, the nice thing about this is that many times that you'll go out to the truck and you'll grab the wrong tool and have to make 2 or 3 trips back to the toolbox. With this, we have the 7.3 fuel filter cap, and as you can see, it fits that, and it'll remove that. It's kind of the mechanic's dream, because having that one and all tool just makes things so much easier and life a lot easier as well. This is the 6.0 oil cap, as well as the 6.4 and fuel filter cap for that as well. The same side fits this. Now on top of that, we see a lot, as you can see with this fuel filter cap, a lot of failures where guys actually try to use a socket or in other times use a 1/2 inch drive to get this off and round it off just like what you're seeing. So what we've designed is not only a socket that fits it from the inside, but also fits it from the outside. So this extension will actually go through the socket and it grabs both sides now so that you have gripping force from the inside and from the outside, preventing it from stripping. And with flipping it over, you can also get onto the 6.7 power stroke if that's what you have. If you've got a solution to a problem that you'd like to see manifest, whether it be a part or you need some help in machining the part, reverse engineering, whatever it may be, we don't just specialize in engines or parts or products like that. We specialize in solutions. So give us a call for any needs that you might have. At Choate Engineering, we wanted to be able to offer something for the customer that he wouldn't have to go anywhere else and shop. So with that being said, we invested in a machine from Rottler, a P69 AHD. This machine gives us capability to port cylinder heads. Now that's something that you won't find in your average machine shop. Now the thing about porting cylinder heads is that obviously it increases the airflow of the port. It reduces the heat of compression and increases mass air density. Now, increased mass air density equals more performance, better power, and better fuel economy. We know that cold air is more dense than hot air, and it'll create a more complete burn. So with that being said, we invested in the P69, and let me show you the reasons why we invested in the P69. We looked around for different machines to do the same thing that the P69 AHD could for us. But there was really no other option when we got to looking and digging a little bit deeper. There were other companies that would offer a machine that might do 5-axis machining, but with porting is very exclusive. It's something that is very specific, and it takes specific tools to be able to do that. Not just the 5-axis machining or the motion of the machine that is able to move in all 5 directions at one time, but not only that, be able to digitize a port, so record all that data from that port, and then be able to manipulate it and machine it all on the fly. Other machines offered a package, but none of them offered a package that was completely consolidated into one type system, except for Rottler. This puts them way above the others in the playing field, and it really made our choice very simple. To kind of give an idea, and not to get too technical on this, I wanted to give you some type of representation and kind of give you an idea of what it would take to actually draw a port and try to machine it, and all the things that might go together just for the end product on this, for the end game of porting. So behind me you'll see we have a roamer arm here, and this roamer arm is what we use here for reverse engineering at Choate Engineering Performance. What that does is it allows us to capture data. Not only will this particular roamer arm do scanning, which will allow us to scan a solid model, but what it also allows us to do is to capture what's known as point cloud data. What that basically means is that a point cloud data is a Cartesian coordinates in space. Basically, it's a dot or a vertex or whatever you'd like to call it, but it's just a location, no different than your mailing address, right? So you know that this is the location that you go to when it calls out this particular spot. So there are multiple locations that are called out, and each time a location is called out from this point data, what it does is it draws a line. What this point cloud data basically does is it sketches out the outer framework of the port itself. Kind of like when you were a kid in school and there was draw by numbers and you would sketch to each point. As you go around in that circular manner, or whatever the port may be, it actually is picking up, and it's sort of like draw by numbers, to oversimplify things. But let me show you what that actually means. Now if we were to take a CAD software like I have here, and we were to go ahead and draw up some sort of sketch for the framework of a port, we couldn't do it just on one plane. Meaning this, if you were to take a piece of paper and you were to draw on that piece of paper, you could draw a port in 3D, but you couldn't actually make that port, obviously, a surface model or actually a solid representation, 3D geometry in space. You might be able to draw it, but it wouldn't be a physical object. In order to make it a physical object, we would have to take layer by layer by layer of paper and draw the circular 2D section of that port until we could extrude it into a solid model. So I'll show you what that means. So here we have a circle. You might look at this, and this may be a seat section or a port section. So this would be the entry of the port itself. And from there, we've created another plane, and we've created a path. Now this is just going to be the path that the port flows along. Everything will be concentric, basically that the circle will be centered around that path. And as we increase more planes, these are the pieces of paper that we were talking about a minute ago, so that you could draw on these in order to make a port. This is what you would need to create the 2D model. So each one of these pieces of paper, or each one of these planes, as they're called, will contain the sketch work or the framework that's necessary to make that port. Now, this is a poor drawing, but you can see, and it makes the point that each one of these dots here is where I've clicked, just like we said, draw by numbers. So we've gone around and we've connected it until we've got a complete loop. Once that complete loop's made, we'll move on to the next plane right here, and we'll draw another complete loop. So we have a hoop here that's centered around this path, a hoop here, and a hoop here. And we'll keep adding more planes and more planes depending on how much tolerance or how little tolerance the tightness of this tolerance draws out or requires. So as we add more planes, we can get more detail to the port. And by doing so, we can follow the original port design, or we can completely alter it and change it. And then once we have all these hoops together and we have a path that we're going to go along, then what we'll do is we can loft this into some type of shape. Now, the port can be shaped however you please with Rottler software or with the CAD software, but what really separates the difference between the Rottler software and another CAD CAM package is the ability to consolidate this and do it all in one setting. So the biggest thing is it's a huge time saver. There's two things. Not only is it a time saver, but you'll find as you're programming that if you're having to make a lot of trips out to the machine, that the end result sometimes might be compromised just because of the mass amount of time that it actually takes just to make the port the exact way you want it. But it's not that way with the Rottler software because it's all done at the machine. The user interface is very user-friendly because everything can be done from where I'm sitting right now. So the conventional way of creating this port would be to use a romer arm, a ferro arm, or some type of system to capture that point cloud data that we were talking about. Each time you pull the trigger on this arm with a probe tip on it, it would draw one of these vertex points all the way around that you see. And once that's done, you'll take and obviously move it over to the CAD and then surface it into a solid model. But with the Rottler software, in the machine, while the cylinder head is in place, we'll take and it will automatically digitize that probe. What that basically means is instead of you investing $75,000 into a romer arm like this one, you're able to do that on the machine. When the Renishaw probe from the P69 or the Rottler machine actually touches off on the port wall, it will create this vertex and create this outline, like we said, sketch by numbers. So once this closed section is done, we can loft it into a surface. Let me show you what I mean on this software over here. Now on the screen, you'll see something similar to what we had over here with the other CAD software, but there's a lot more planes because we can get a lot more detail on this. So we have the blue hoops that you see, which are going to be the outline for our port itself. And the great thing about this is all we have to do now is click on one of these hoops that you see, right, or closed sections. And once we click on a closed section, it'll actually pull up over here in our 2D profile view. Now each one of these dots that you're seeing here can be manipulated, no different than what you would get if you were to use a 3D scanner. So each time that you see one of these dots, that's point clouds that it actually has stored, and we can change it, we can manipulate it. Now that we've got all our planes and we've got all our closed sections, then what we'll do is we'll loft this into a solid surface. Once it's lofted into a solid surface, you can see your port. You can rotate the port around, zoom in on the port, see any areas that might need attention. You can manipulate it in any direction you want. If there's a certain area, and then we'll just make a drastic change so that you can see. We'll scroll out, we'll grab half this port and just pull it up just for demonstration purposes. Obviously you wouldn't want a port that looks like that, but it gives good illustration to the powerful software that we have at our fingertips to be able to manipulate the port any direction that we like. Once this is completed and you're happy with the outcome of the port and the shape that you want, it's very simple from there. We'll click to the next tab and it'll generate a toolpath. All the lines that you see, if we zoom in, you can actually see are toolpaths that our lollipop cutter will actually follow. So it doesn't stop there though. It's not enough to be able just to draw a toolpath on this model. We need to know if it's going to shank out, if the cutter is going to actually hit the port and destroy our cylinder head or destroy our tool and our spindle. So we can take this and tool hover to verify toolpaths, or we can verify the toolpaths on all. Let me back out and show you what the tool hover to verify toolpaths looks like. This red tool indicates our lollipop cutter. As we go down into the port, you can actually see all the areas of pivot that the cutter will have to go to in order to keep from shanking out. If we didn't have this software, we wouldn't know whether or not it was safe to run this program. That's just something else that makes this software so much better than the rest. Because again, it's consolidated, it's all done in one. So we can go from the Digitize tab and record all our point data. We can go to the Program tab, manipulate our software, and manipulate the port how we want it. Click on the toolpath, generate a toolpath how we want the tool to run, and what the step overs, the speeds, the feeds, whatever things of that nature that we might desire. And then click on the auto cycle and come and we can actually look at the different parts of the toolpath that we want to run, or maybe we don't want to run but half the toolpath. We can click on these check marks in these boxes so that we can see, and we can go ahead and run those ports. We greatly appreciate you coming to the shop and hanging out with us today. It's been a delight to have you in, and we hope that the takeaway has been our passion for the industry, but also the investment that we've got, not just in money, not just in time, but we know that when we have a customer come to us, we don't take that lightly, and that's something that we are very serious about. Your trust is extremely crucial to our business, and it's something that we respect very highly. Because of this, we want to make sure that your investment in Choate Engineering Performance is very well founded. And that's the reason, as you can tell today, going through the shop, we've invested in the best of the best.
Hey everybody, we're back here at the Engine Performance Expo. I'm Joe Castello along with Cass Choate, Lake Speed. Cass, that video was awesome. We had a good crowd in there in the lounge, like watching you just kind of go through the paces, talk about different elements of the machine, talking about setting up the office. Now we're going to give people an opportunity to ask you some questions live. I know you're ready, but you put a lot into putting that together. Great job.
Yeah, anytime we have open Q&A, I feel like I'm in the proverbial dunk tank, but that's okay. I'm looking forward to it.
Well, we'll do our best, and I will ask everybody out there, when you type a question, think about the whole question as you type it out. Just because there's been some like half questions, like is this question mark? And we need more than that, so please help. And Lake, obviously, there's a lot of information being exchanged right now.
Oh yeah, hopefully maybe Cass, for your good, maybe Billy or somebody will throw you some softballs, you know.
Yeah,
type
yeah,
deal,
definitely.
You know,
I appreciate it. You know, we're both from the Memphis area, so just
take it easy, right?
take it easy. Yeah, remember that.
Lob them up, and I'll work the questions. And it looks like we got a little bit of a hangover from John Callie's in the Fierro talk, which is kind of cool.
I was talking to him a minute ago.
Exactly. And what else has been happening is just the conversations between like-minded people out there in the chat section. You know, they're at home, they're watching, it's Saturday, they're having a good time in between whatever they have to do, and they're connecting with one another, talking a little bit about what's going on. I see Kyle Fickler is out there. What's up, Kyle? Thank you very much. And it's just been really cool. There was a lot of talk about the G programming, talk a little bit, the G coding. I saw a lot of feedback about that and just how there might be a learning process if that's what you're used to. Right. There might be a learning process, but once you get through that, then you're much better off.
Yeah, the G coding is definitely the industry standard for machining. I mean, that's pretty much FANUC controllers, whatever it is. There's certain machines like, say, Mazak. They use Mazatrol, but that's just the standard. The issue that we have is a lot of times you're going, and people really have to understand there's a huge difference between engine machining and part manufacturing.
Okay.
And a lot of the guys that are engine machining are terrified because G-code is just something of a foreign language to them, right? But these guys have been doing this for 30 years, right? They've been making holes in blocks and you know, making sure concentricity in seats and everything else. They understand everything that needs to be known about engine machining. But when it comes to the G-coding side, it becomes like I say, hieroglyphics. Rottler really does a great job of making that bridge between the engine machinist and being able to have the outcome with block machining, and doing so by removing the little bit of the scare of the G-code and using conversational programming.
Oh, that's nice, yeah.
So, in other words, if you had something on your machine, you're trying to move, you know, in an X location, it's just as simple as how far do you want to move over, you know.
Right.
So it is really for people that are not of that background. So
That don't know the language.
That don't know the language.
That's what I do. We talk about software language. There's a reason, because it is a way of communicating, and until you know it, it's like going to a foreign country that you don't know the language.
That Rottler's the translator.
That's nice, yeah, great.
Very interesting. All right, so send in your questions, Q&A for Kaz and obviously Lake, and the whole operation has been great. This is the first one for you, Kaz. How do you develop the port shapes when you offer ported heads?
So we have an in-house program for all of our cylinders through testing on flow bench, and I'm probably going to go throw that away after hearing Warren Johnson. So absolutely amazed at the level of knowledge that guy has from the pro stock world. Diesel application, definitely turbocharged on pretty much everything that we do. So we do a lot of testing in-house through not just flow bench, but actually real-world testing. And so there's the nice thing again about the machines, and that's been shown over and over in this episode of Engine Expo, is the ability to change on the fly. So we can take something off the machine after we test it in real world, and then change that shape and be able to do it in a very quick manner so that we can get the outcome that we want. Most of that's developed on the bench, on the street, and on the machine as far as that's concerned.
Yeah, that iterative testing, I think that's kind of one of my big takeaways from this whole week, is the fact that cycle time between concept and product is become so short now. The ability to just race into the future, no pun intended, is available. You could, I was talking to WJ yesterday about me and Jake Raby doing that testing with the Zuma bore, and just how fast. I told Jake the other day, I said, I think we did a year's worth of testing in 1 week.
Yeah.
Just because of when you have that, we'll call it the framework, but the compartmentalizing where you can sit there and just go, boom, iterative change, and it's just step change, step change, step change. You can learn so much because you're not changing a lot of variables, but not giving away. There's a whole feature coming up later where we're going to talk a lot about testing and the proper way to do testing. But I think that's pretty neat. One thing you were watching the video, you saw lots of chips being made. And shout out to our buddy Kevin Sudaker, who works at Total Seal, for this one-liner. He said there are metal putter honors and metal taker offers in the world.
Is that the technical term?
Yeah, as a technical term, yeah, it is. You know, so obviously you're doing a lot of metal taking offing.
Yeah.
So
that's my title.
right, exactly. Yeah. So I'm the hydrocarbon guy. You're the metal taker offer guy. So when you get down to that, to the metalworking, there's, you know, some thought process, dry machining. There's some guys, oh, we got to have oil. Some guys, you have coolants, and and not to say that one's right or wrong, but talk a little bit about your experience and where you kind of feel appropriate and not appropriate. And
yeah, you know, a lot of guys watch videos, and the first thing that they, especially if they're from the machining background for part manufacturing, you know, cast iron uses, or cast iron has a lot of graphite, which is, that's lubricating, right?
Exactly.
And, you know, they might watch somebody bore a block and go, you know, why are you not using coolant during this process? But that's because of the lubricating properties, which also goes back to a whole deal we talk about. We've got a lot of guys that ask us about valve guides and different things like that, and why we use a matrix valve with graphite. But as far as that's concerned, you know, aluminum is a gummy material.
yes.
And, you know, when you try to machine aluminum, it sticks to whatever.
Yes.
It machines really nice. It's easy. You can run a super high surface feet per minute, and it's a lot of fun to watch the chips blast off. But if you're not running a coolant on that, it tends to gum. Your surface finish is just going to go. Absolutely. So.
Which is counterintuitive. I mean, if we, you know, not to talk too high over people's heads, and we're not trying to say people don't know what we're talking about, but the reality is when you're cutting something, just because it cuts easy, the fact that there's a built-up edge on the back side of that tool, and it's that built-up edge because you are cutting that material, and if it sticks, you have the same material that sticks together. So now you create this surface roughness because you got this patchiness coming behind it that you weren't intending to happen because you were just trying to cut it. So that's what we're talking about. That clean cutting is that built-up edge. So it cuts easy, but the surface finish is very, we'll call it irregular.
Right, absolutely. And, you know, being able to keep, you know, if as a diesel guy, you know, we see melted pistons coming all the time, right? So we know what the temperature of aluminum, cast aluminum melts at. So you also have to consider, while that chip seems like it's flying off there at a rapid rate, you have to consider the temperature of the end mill as it's contacting that area. And what happens is that microfusion type process that takes place. And once that happens, it destroys that leading edge of the, or disrupts the leading edge of that end mill, and like you said, it definitely affects the surface finish, and there's no other good way around it other than a good coolant that whether it be a synthetic coolant. We use a couple of different coolants in our shop, but there's really no other way around it than that.
All right, got a couple questions coming in. Keep them coming. This one from Frederick. Do you know if the dry test run feature is the same on all the Rottlers?
The dry test run feature. So simulation mode on the Rottler. Simulation mode is going to be something that you're probably going to be using if you're using RCAM or RPath or what is the latest version, the 4C software. That simulation mode, if you're running the latest update, there are some differences. They've definitely gotten a lot better with the graphics. So simulation mode has changed through, like I say, the RCAM and RPath and the 4C. So it's different. Obviously the end goal is the same, but the graphics have certainly got a lot better. They've updated the software now where you've got a capability of importing your Cat40, whatever the tool that you're using, different things like that, so that it makes it a little bit more realistic.
More questions about port design. Is it still beneficial to develop a port design by hand, or do you just use the Rottler software to completely design from scratch and then flow it from there instead of a step-by-step process by hand?
So port design is definitely, it's nice when you can go ahead and have a port that's designed by hand, because instead of altering everything, sometimes when you're trying to alter it in the machine and you're looking at the port, it would be easier in reverse where you can digitize that. Then sometimes it might look good at an angle, but you can actually rotate it. There's a lot of parallax there, and you don't know 100% maybe what's going on. It might look really good at this one angle on the machine, but if you can do it by hand and you can see it, you know, in 3D and live, and you can rotate it around in there. But doing it by hand is really my preferred method, and then digitizing it, getting exactly what I want it, because there's no quicker way to manipulate something, just reaching over and doing it by hand. So once you get it and you're satisfied with one port, the CNC side of things goes from, he was talking about being able to CNC port something back in the 90s and making a huge difference in the amount of time it took to nowadays how much faster it is. The idea of CNC porting is consistency, and first and foremost is time.
Oh yeah, that was the huge thing. I know in NASCAR, my dad having his own shop and everything, that was the thing that we never had the big CNCs because we were kind of past that by the time toward the end of Dad's career. But not very long after that, going to Gibbs, the fact that, oh yeah, you can go in there, work on port designs by hand, find a set of heads that really flow well, digitize them, and now you can, just like Doug said, knock them out. You got it. And then you can have them every race.
Right.
It's not like in the even mid-late 90s, there were some situations where there was a championship won by a car, we won't name anybody, that they had a set of cylinder heads that were just better than the rest of them, and they literally reworked those heads for every open racetrack they went to. If it was a mile or bigger, that was the best head.
Yeah.
And they ran those same heads all year long. Because it just, the technology just wasn't quite there yet. But then within a couple of years, everything's being made CNC.
And that's why going to the backup engine was a problem then.
And
Now going to the backup engine doesn't matter. Everyone is just another one.
Better. Yeah.
Exactly, yeah.
Which is amazing for the people that are fans out there. Question regarding the machines. Can the machines communicate with each other, and are they able to load files from a remote source or location?
They can. So as far as communicating with each other, I'm not aware of anything, and there's really very little reason that you would want to necessarily do that, because at the end of the day, if you go and you bore a block, you're going to want to check it with a dial bore gauge just to make sure there's no discrepancy. Now, that being said, in the Rottler block software, what you can do is you can probe the bore, and after you probe the bore, it will output and give you like what would be, if anybody's familiar with maybe any other kind of CNC machines, a macro variable that might output a dimension. Rottler does that. So when I get done boring all the holes, if I wanted to reprobe them, it'll give me an output of a quantitative value of each cylinder. So that definitely would be handy. But at the end of the day, I'm the kind of guy that's going to reach for the dial indicator, dial bore gauge, and I want to, I want to measure it. As far as being able to wirelessly drop a file into a machine, there are ways that Rottler has that you can actually see your machine running from your cell phone.
Yep.
And it can tell you when it's done. So that's
pretty nice.
It's pretty nice. It's pretty nice. That way you can call the guy in the shop and say, "Hey, it's done.
Yeah.
On another part."
Reload the pallet changer.
There you go. Right.
There you go. Can the Rottler equipment give you the area of each section of the port?
It can. It gives you cross-sectional area. It will give you the port volume. It will give you the distance from the manifold to the seat section. It will give you distances between planes. It will give you a lot of information there, which is nice. That's huge, because when you're designing a port, we're looking at cross-sectional area versus flow, how that's going to affect velocity. All those things come into play, and being able to have that data just readily available allows you to make those quick changes like we've been talking about.
James wants to know, can the 69 ATC and 69 HP do similar work?
The HP is the high performance. You would think I would be a Rottler rep with all this, right?
I'm impressed, by the way.
I need to talk to
Andy,
Andy, you need to put me on the... no, if I, really I could not... I definitely could not talk about something so passionately if I did not believe it and I did not use it every day. So it does make it easy to sell things.
Right.
And it's not a sales pitch. I'm just giving you the straight up story of what I'm dealing with every day. The HP is, and I love machines. I love machines. So,
metal taker offer?
A metal taker offer, professional, So, I try to stay up with the latest and greatest and what they've got. The HP is just for the higher horsepower, and it can, I think the RPM spindle is like 20,000. Okay. Can it do the same thing? Yes, it absolutely can. It's just a little bit later version, but also with the upgraded spindle. So
got it. Keep those questions coming. Keep those questions coming.
So let's go back for a minute while we're waiting for some more questions. Back to the coolant thing.
Yeah.
There's a big question. You mentioned semi-synthetic, neat, full synthetic coolants. So when you get into a coolant that's water-based, essentially metalworking fluid, what is your shop's procedure in terms of checking refract. And if you don't know what I mean by refract, these water-based coolants are actually a water-oil emulsification.
Right.
So if you're familiar with, let's say, Italian dressing, you got to shake it up because water and oil don't want to mix.
Right.
But in this case, we chemistry, hydrocarbon guys, we do some special magic and make water and oil mix together so that you can get the cooling effect of water on that part, let you run higher feeds and speeds, but then you add the lubricity because water's a poor lubricant to have it cut properly. But when you have that mixture of water and oil, maintaining that right balance of water and oils is important, and the refractometer is the tool you use to check that. So talk a little bit about how you maintain your coolant.
Well, like you just mentioned, water and oil. Water obviously is going to evaporate.
Oh, yeah.
So that is something that's going to have to be checked weekly. So through a refractometer, checking the Brix value, we're looking to make sure that we maintain the right lubricity and content there. So that's something that is extremely important for the surface finish of the part that you're working on.
Tool life as well.
And that's the next thing I was absolutely going to say is that, and we use diamond stones where we're at. So that even still, it's extremely important. If you want the right outcome, there's a recipe like you're always talking about. So that's
soup.
It's yeah, absolutely.
Yeah,
Like,
see, they're catching on.
You know how I was just thinking, when we were off camera, how many people I've told that I know Lake Speed Jr. and they're like, is there any pictures or anything you've got? And I looked through my phone, I couldn't find them. You don't know how many postage stamps that I'm going to save money on and Polaroid pictures
Hey,
that I don't have to send out.
we talking
Right,
about.
exactly. We've got it. Now, myself included. We'll share stories someday. It is a pretty big deal, by the way,
man,
just to be here and be a part of it. Here's one. Ken Rotler, let's see. I think we just answered that. Rotler can communicate. Oh, someone had asked about if the Rotler machines can communicate and diagnose if there is a service issue. So can the machines...
Yeah. Cool.
Yeah. I was thinking about when we were actually filming one of these videos at Roush Yates. They remoted in and they made some alterations to the program in order to achieve the feeds and the speeds that Ed wanted it to do with the diamonds they had in order to achieve the surface finish they want. So that was kind of cool because they're Seattle, Washington, and we're in Mooresville, North Carolina. And these guys remote in, and 10 minutes later, machine's spinning up and doing what it wants to do. That's incredible.
Yeah, these they have Bissing coder motors, and they can tune. That's the neat thing about it. You can watch kind of the sine waves and graphs there, and I've got a lot of friends that work there, and they'll leave me messages on my screen. Christina's one. I want to give a shout out to her, but she helps a bunch. If I've ever got a question on something, but they can come in and actually tune the motors and make sure everything's running in tip-top shape without actually having to be there, which is, man, that is.
Oh, eliminating a service call? That's huge.
That is huge.
Because nothing breaks when you have a break coming up.
No,
it breaks the day you need it to be gone. It's like, I got to ship it today. That's when the machine breaks. It makes the last part.
It's like having a Samsung refrigerator. Now you just put your cell phone on. I don't know if you've seen that, but diagnose it. You put it into the top corner of that. I mean, it's the same thing.
When you need milk, you need milk.
You need milk.
You need milk. Go buy some milk.
That's awesome.
A couple more minutes here for our question and answer session. If you've got a question, obviously the video was very informative, and we're learning just so much over the course of these past couple of days about those two areas, like making parts is one, and machining parts is a different thing, like machining an engine and otherwise. But everyone seems to be super happy with what they are now capable of doing in terms of it's quicker to innovate. You can just get the job done quicker and more efficiently.
Right. Yeah. And with the software that we have available now, it's, again, and I said this before, but your imagination really and truly is the limiting factor. That's, guys go, well, that's a big investment on that, and it definitely is. I'm certainly not going to paint a rosy picture and just say, hey, this is this. You're not going to pick one up at the yard sale, okay?
Right.
Yeah. But the great thing about it is just the ability to be versatile and not just, this isn't an F2 boring bar anymore, right?
Yeah.
This is something that is and I look at it and I use this word a lot, but it's a transition machine, right? So it allows me to go from being an engine machinist to being an engineer to my own parts, whatever it is that I want to do. Man, it just gives you a tremendous amount of versatility to whatever end result you might want. And investing in yourself and the education, that's something that admire.
That's what you got to do.
Yeah, you're always trying to learn to take it to the next level, but you will at some point in time. You're going to be handicapped by the equipment that you have, and with that, it's just
sky's the limit.
That's it.
Joe, you know, this whole conversation reminds me of the episode we did at Hidden Horsepower with Joey Arrington. And Joey was talking about how in the old days in NASCAR, a hot rod part, a racing part, was a production part that you hand ground or welded on and you manipulated. Now, you're saying the evolution is then you went to making your own parts.
Right.
And now, like you're talking about, is I can make whatever I want. I'm not limited to what my lathe can do, that these 5-axis machines can do anything. And now, like Warren's saying, you can do it in the same day.
Right.
You can make this part and have it in the engine that afternoon to find out if your idea was a good idea or a bad idea. And trust us, we all act like we're smart. We do most of our learning by stumbling and bumping our toes, building on our elbows, bleeding. It's the mistakes is where we learn most of this stuff that makes us look smart, because we're not.
Absolutely. I think I've put it in reverse a few times, and because I've missed speed bumps and potholes in my career, and I've put it in reverse just because I think I missed one and ran over it. But, it's definitely, it is a learning curve. And it's one of those things where people want to go, okay, well, how do you get into this? The truth is it's not, you're not going to wake up one day and go, poof, I know how to CNC program, I know how to machine blocks, I know how to make things go faster. No, the truth is unfortunately, you're just going to have to do it like everybody else did, whether you're Warren Johnson, whether you're John Ghazi, whether, you know, it doesn't matter. You're going to have to get up, you're going to have to do it, and just that drive to make it happen. And you're going to make mistakes, you're going to have failures, but keep pressing forward, and when you do that, something's going to break loose.
It's the flywheel effect.
It is.
When you start pushing it initially, it's hard,
and
it hurts, and you feel like I'm not making any progress. But if you stay at it, just keep pushing at it long enough, eventually it starts gaining momentum. Like I said, at some point, that momentum just takes off, and then it just, like, everything you do becomes easier.
Absolutely.
Well, I like the analogy, and I appreciate that. And there's been certainly a lot of analogies like that. But the imagination, once you really develop the imagination, that's when you're going to be able to use the tool to come up with the most amazing things, because you've got a lot of time in and you've been activated with your imagination. Cass, great job. Any final thoughts?
Man, I'll tell you, it's been a pleasure. Always, it's been a learning experience. And I want to say this, being that this company for sure has been a big help to me, and I said this earlier backstage, there have been 4 guys that have made a huge impact in my career. And you can want and will and wish all you want, but you're going to have some folks in your corner.
Yes.
I've got guys, AERA, fantastic place. Chuck Lynch has just been a tremendous help, and a dear friend of me, Ed Keebler. I mean, I can't say enough great things about that man. He's just, these people really do. This is I can't imagine being in a better industry, because you've got those, Randy Neal and Darryl, those are all guys that have just really taken taken their valuable time and invested in us, and in particular in me. And I'm grateful for that. I never want to, take, I always want to, if I have opportunity, to take and say thank you for that. So I appreciate that.
Excellent. No, you've done a great job. Wealth of knowledge, so much fun. And so we're going to continue to move forward. It's our final day. We're going to give away a short block a little bit later. But right now, this is an area where I think everybody is very interested. People who assemble engines, the tips, the tricks, the shortcuts, the way to do it the right way. And you got a lot to do with this next one.
Oh, so like you said, imagination and tools. This is the video. John Ghazi, the master idea guy, master tool maker. Take it away, John.
What a day, what a day, what a day. My brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.